My name is Dietrich Albrecht. This is my wonderful colleague, Almudena Gonzalez. We both are working for company UBE. I'm here from the commercial side, and Almudena is our engineering specialist for our hydrogen applications. So, it's a strong light here. No? Green, okay, yes. So thank you for coming. We have a lot of people here in the space, and we will elaborate a little bit on our activities and hydrogen storage solutions. I will talk a little bit about the company and the technology evolution in the market, and then Almudena take over the second part, and she will happily explain you our material solutions and molding technologies. So first of all, yes, okay. We are working for UBE Group. UBE Group is a chemical company. We are active in polymers, mainly nylons, but not only. We have a history of more than 110 years. We have a revenue tag of approximately 5 billion euro. So we are not a very big chemical company, but we are also not a small chemical company. We have footprint of our operations all over the world. So we operate global. We have a nylon plant, for example, in Japan. We have a nylon plant fully back integrated in Thailand and also in Spain. And we have compounding facilities that is relevant here for our topic today, also all over the world, in Thailand, in Japan, in Europe, and in the US. So sustainable mobility is a very important topic for us. I'm working for the Composite group. That means we are doing all our nylon 12 activities and all our compounding activities globally. We have in the group revenue of approximately 300 million euro, and you can imagine around about 80% of that is automotive. So up until today, we are strongly vested in the automotive industry that is traditionally related to a combustion engine. But since decades, we also have activities in what we call sustainable mobility. And when we talk about sustainable mobility, it's obvious, it's all coming to your mind. We are talking about e-mobility and another type of e-mobility, that is FCV, fuel cell vehicle mobility. And this is just a little appetizer here. You know all by yourself pretty well. When we have a look at both types of mobility, we are talking about relatively close systems. They are not so dramatically different from each other. What we can say is range is one of the key features for that was maybe in the past limiting the deployment of e-mobility, but range is not the big issue anymore. We all know this. Every new model that is coming to the market has more range. You can drive longer distance. And range is not really any issue anymore. And yes, of course, you have the charging cycle in the e-mobility. That is maybe the let's say the most inconvenient part of the e-mobility. And in the hydrogen car, you have the advantage you refuel the car as fast as basically you would refuel a fuel car or a diesel car. So that is probably a good advantage, but to be honest, we are working in both fields from our side with our material solutions. So we are pretty happy with both evolutions. What I want to say, on the other hand side, is you know where the e-mobility is. Millions of cars are going out now in the market, freshly produced from all the OEMs that we know. In China, the market share is already very high. Yeah, if we have a look at the FCV car, we have put here on the left side, maybe I can, no, this is not working, okay. We have put on the left graph the deployment numbers, and we are here in the thousands. We are not in the million, we are in the thousands. And of course, we can ask ourselves a little bit why and what is the reason that the FCV car is not yet so well deployed. We can say one part is coming from the infrastructure. There should be more hydrogen stations where you can refuel your car. This is clear, we all know that. The infrastructure is growing, but is by far not in the deployment phase that the electromobility is today. And on the other hand side, let's have a look at the cars available. The cars available today is basically the Toyota Mirai and the Hyundai Nexo, among also other models that are in the market. Please, this is not the complete picture here. But these are, let's say, the two flagship cars that really make the numbers on the left chart. So these are real sales on the left-hand side, the FCV registrations. And you can say the two models make the 95% of these deployment numbers. But the good news is the commercial sector has an entirely different picture on the electromobility. There's a lot of work in the electromobility in the commercial sector for trucks and vans. We can also see that, but range, refuel cycle, that is becoming a different story in the commercial sector. And here we see a lot of development ongoing for trucks based on FCV drive. We put here already the commercialized Toyota Solar or the Hyundai Accent as an example. And we expect a lot of new launches, also among Nikola, for example, in the US. But basically also Stellantis is very active, but Volvo is active, Daimler is active, Traton is active. Bosch is very massively active for the commercial sector, for the commercial transport sector. So there's a lot of movement in the where the electromobility comes a little bit more to let's say its limitations. Good. And now I would like to give the words to Almudena and going for the technical part. Thank you very much.
Thanks, Dietrich, for making the first part of our presentation. Now I will continue with more details about the technical part, especially talking about the hydrogen storage system for the Type 4. And probably most of you know how is the composition of the hydrogen tank. We have three different layers. The inner layer of the tank is made of polyamide, that is the material that we produce. And the function of the polyamide is to prevent the hydrogen permeation. Then it's covered by a layer of carbon fiber, reinforced plastic, that prevents for the to improve the pressure resistance, that is very important on the function of the tank. And finally, for a glass fiber reinforced plastic for the surface protection to avoid heavy abrasion and so on. So when we talk about tanks, and especially for mobility, we need to think that all of them, they need to be certified according to global regulation. And you can see in the list the different regulation that exists at the moment. Probably some of them will be renewed in the next years, but as you can understand, due to the storage of the hydrogen, they are really, really standards, very high standards to comply with the function of these tanks. So if we think about the requirements, we have, in the case of the polyamide, of course, the level of the permeation of the hydrogen is very important. But also the polyamide has a role in the case of preventing the blistering from the liner to the rest of the materials that made the tank. And of course, the performance at low temperature, because as probably you know, the tanks operate between -60 degrees up to 85 degrees. and of course the pressure. So at this moment we have in the market tanks that operate up to 350 bars, but we of course have also up to 700 bars. So a summary is really important to cover all these requirements that are not easy, and especially for us to develop our polyamides that can comply with all these requirements. So if we talk only about the liner, the polymer liner, at this moment there are different technologies to mold the liner. And so we have already well established the injection and welding process. So this is what you have already in many cars that are available in the market. But of course, there are other companies that they are working in blow molding, also in rotomolding, as you can see around here. And of course, there is another alternative that is the tube extrusion and welding, and together with the injection. So what is the decision when you want to make a liner? Based on what? No? What is the factors that you select one technology or the other one? Because there are several. For example, one very important is the size of the tank. You cannot produce a very big tank, for example, for heavy-duty vehicles with injection. Especially, for example, also the diameter with the tube extrusion. So there are some limitations, but also there are some advantages. So, apart of that, another important point that, of course, every company is looking for is the cycle time. So you don't have the same cycle time in each technology. It depends of each one. For example, in the blow molding could be less than 3 or 4 or 5 minutes, but in the rotomolding it will increase a lot. And also, there are a lot of difference when we talk about the quality of the liners. We cannot obtain the same quality with all of the technologies. So when we look to the permeation, or we look to the wall thickness and the stability of the process. So, of course, it depends on the needs of our customers and of our tiers that are producing the liners and what they offer at the end to the OEMs. Okay. And now, the last part of our presentation is to go more in detail about UBE products. Okay. So, as Dietrich has mentioned before, we are a chemical company. We have integrated in our process from the monomer to the compound material. So we have a unique polymerization process that allows us to produce polymers, polyamides from very low to very high viscosity, which is very important because depending on the viscosity, you can use one technology or other. And we can produce from short chain, polyamide 6, up to also long chains like polyamide 12. Apart of that, we are also producer of copolymers, the copolyamides. That is also very interesting because they have different properties from the homopolyamides. A very important process in the hydrogen tank is the compound process, because we need to modify our polyamides to get especially the properties at very low temperature. And UBE is not only producing polyamide that are well known by Ubesta, UBE Nylon, and Dinalon brand, but we also include in our portfolio different polymers like polypropylene, PBT, and PPS. So here in this slide, you can see our portfolio of materials for hydrogen tank. We have at the moment now 4 commercialized or semi-commercialized products. There are different materials, of course, depending on the technology, because I would like to comment that we have customized and designed our material especially for hydrogen. We have not readapt materials that we have in a different business for this application. So the success on our business, especially for injection with the 1218 IU, is the result of many years of development, especially with the Asian OEMs, to develop this material. So, as I said, we have for injection and welding process the UBE Nylon 1218 IU, that is a polyamide 6 base. This material is already approved by Toyota and Hyundai for the Mirai and the Nexo. And we also have 2 different materials for blow molding process, a very high viscosity materials in order to achieve more than 2 meters length tanks. They are the 1230 IU4 and the 5033 IU. One is a polyamide 6 base, and the other one is a copolyamide. So they are similar in terms of processing, but they offer different, let's say, characteristics, no? And for example, in terms of permeation or pinch-off. And the last one is the rotomolding material. This is the powder grade. This is our UBE nylon PRM 101U. That is also a polyamide 6 base. Okay, let's talk a little bit about values. Of course, the most important, because it's the main role of the polyamide, is the permeation, the hydrogen permeation. Here you can see a benchmark between 3 of our materials compared to polyolefinic. So as you see, the polyamide 6 has a different scale and is much better than the HDP that is well known, and, for example, in the storage. So if, as I said before, especially in the case of mechanical properties, it's very important to modify the material at low temperature. So our 1218 IU has a tensile strength at break of 20% and minus 60 degrees. And you see, compared to other materials, it's quite different. And another important property, especially for the blow molding process, is the drawdown resistance. As you see, we have different alternatives depending on the size of the mold. And the last topic about technical data is the welding process. Welding process scares a lot to the people in the production of the tanks, but in UBE, we have already developed the best conditions for the welding process of our 1218 IU, especially in terms of temperature and welding pressure, to avoid any problem of deformation or oxidation layer that can compromise the welding line. So just to summarize our presentation today, so we believe that the hydrogen mobility is a complementary alternative to the electrical vehicle, the battery electrical vehicle, that has their space in the market, especially for heavy-duty vehicles, where you need high capacity of hydrogen storage. Another important point is that we offer our service to develop our materials in order to comply with all the requirements, and we work on that in customization of our products. And the last one is that our portfolio, of course, is also the result of working for several years with the OEMs, because it's very important to have this communication with the OEMs and the tiers in order to have the best product and to offer the best service. And this is all. Thank you very much for your time.
Okay. So this could not be more than a snapshot in a couple of minutes. We have tons of data. We are more than happy to work with you on an individual basis, on a one-by-one basis. Please approach us anytime with your ideas. And we are totally happy to share our know-how, our really 20 years deep know-how, starting from the first Toyota Lincoln on the road as a prototype to today. Thank you very much. So if you have questions, yes. Yes. Please, any questions? Come on. Something.
A question or problem?
Or problem. We love problems.
I didn't see you, I'm sorry.
Thank you very much for the presentation. David Ruggi, material engineer at Plastic Omnium. We are here at JEC talking about composites. I know you have a wide portfolio of material. So for the next generation of hydrogen storage, like Type 5, or we can call it 4.5 if we want. Mm-hmm. Do you have a composite using your product as the matrix? Thermoplastic matrix?
Yes, we had, David, thank you for your question. Yes, we had activities in the past. We, strictly speaking, in Japan, we have our own system to polymerize from caprolactam in situ. That was one of the ideas to apply for 4.5. But it's not so simple to polymerize 20 millimeters. Okay, so that's one answer to your question. Maybe you have something else, Almudena? Yeah.
It's okay. I think it's
yes.
a good answer.
Yeah. But theoretically speaking, a monolithic structure would be the perfect world. Yeah. So you have the nylon liner, and then the composite also in thermoplastic, and preferably also in nylon 6. This would be like the paradise for tank application. Yeah. Yes. Thank you. So somebody, please, come on. Okay. Then it seems it was satisfactory. Yes. No questions. Thank you. Thank you very much.
Thank you very much.